Quick, what did one axon say to the next axon? You've got a lot of nerve. Oh, synapse. So today we're going to be talking about excitation contraction coupling. And there are 10 steps we should remember. First is the flow of sodium down the axon to trigger voltage-gated calcium channels, causing the release of calcium into the axon terminal and triggering exocytosis. After the exocytosis of acetylcholine, acetylcholine will bind to its receptor on the sarcolemma, causing sodium channels to open, and this will cause depolarization down the sarcolemma and will trigger the DHP receptors. The DHP receptors will cause rhyodine receptors to open, causing the flow of calcium outside the sarcoplasmic reticulum. After this, calcium will find troponin, and then the whole complex will move tropomyosin out of the way in order for actin and myosin to cross-bridge cycle. After that, the sarcomere will shorten. So first, let's talk about the 4 places we should remember. This is the axon, the sarcolemma, the axon terminal at the neuromuscular junction, and we're going to take a closer look at the T-tubule and the sarcoplasmic reticulum. First, we'll start at the axon, where sodium is going to flow down the axon toward the axon terminal and open voltage-gated calcium channels. Sodium does this by having a positive charge and moving down the axon, which is negatively charged. So this is what causes the voltage-gated channel to open. After this, the calcium channels will open, and calcium will be released from outside of the axon terminal into the axon terminal, and it will trigger exocytosis. The molecule being moved outside of the axon terminal will be acetylcholine, which is a neurotransmitter. And so acetylcholine here is moving outside of the terminal, and it's going to find its receptor. This receptor is also known as the nicotinic cholinergic receptor. Once it binds to its receptor, it's going to cause another change. This will open the sodium channels on the sarcolemma. After sodium will go past its channel and into the sarcolemma, it will cause depolarization across the sarcolemma, opening more sodium channels and creating a domino effect. Here we can see the sarcolemma as a whole, and we can see the depolarization moving outward and going towards the DHP receptors. Now the DHP receptor is what's going to be triggered by this depolarization, and it's going to cause a change in this DHP. Once the change is happening, it will open the rhyodine receptor, and it will cause calcium to flow out of the sarcoplasmic reticulum. And from here, calcium is going to look for troponin, where it will bind to the calcium receptor on troponin, and troponin is going to move tropomyosin out of the way so actin and myosin can cross-bridge cycle. And from here, the sarcomere will shorten, and that's it.